Hello Earth Science students, here's our lesson on weathering and erosion. First, let's distinguish between the terms weathering and erosion. They don't mean the same thing. Weathering is the actual breakdown of rocks into smaller pieces, which we call sediments, and then erosion is the movement of those broken down sediments from wherever they were broken down to another place. Weathering and erosion, both of these processes can be carried out by natural things like wind, water, ice, gravity, like stuff rolling down a hill, and then some organisms can also contribute to weathering and erosion. We're going to focus more on the types of weathering in this particular lesson. The first main type of weathering is called mechanical. This is also sometimes called physical weathering because this is when physical forces break down rocks into small chunks called sediments. Like you can see in this example here, you start off with a big rock and then it gets crushed up into small little chunks called sediments, and that's physical or mechanical weathering. Another example from everyday life is like ripping up a piece of paper. As you rip it into smaller and smaller pieces, it's still paper, it's just smaller pieces of paper. And physical or mechanical weathering occurs faster in colder climates. Okay, let's go over the specific types of mechanical weathering. First, we have what's called frost wedging, and this is the reason that mechanical weathering happens faster in colder climates, because when during the day liquid water gets into cracks in rocks, then at night that water freezes, and as water freezes it expands, and so then with repeated cycles of that, every time the water refreezes it expands that crack a little bit wider in the rock until eventually the rock can be broken. So this is how we have big cracked boulders like in these two pictures here, and then also in Montana this is how potholes form in the road. Water getting in during the day, freezing, breaking off chunks of asphalt, and then repeating that cycle over and over. Next type of mechanical weathering is called abrasion, and abrasion is just when rocks are scratching against each other. If something is abrasive, that means it's scratchy, and so when rocks are tumbling against each other, especially like in riverbeds when they're being pushed by water, you can have this abrasion action happening. Softer rocks that are made of softer minerals are much more susceptible to rocks that are harder. So like, for example, a rock that would be very resistant to this type of abrasive weathering is quartzite, because it's made of hard quartz minerals, and this produces characteristically rounded, smooth rocks like you would expect to see in a river rock. The third type of mechanical weathering we have is called unloading, and unloading occurs when you have something especially like a batholith that forms deep underground with a lot of pressure on it, and then over time as the ground above is weathered and eroded away and it exposes that plutonic formation, then as the pressure is reduced it will kind of make that rock peel away in layers. So that's like this picture down in the corner here. If you've ever seen like a big chunk of granite that's kind of peeling away in layers like this, that's due to this unloading action, and as those layers peel off, that process is called exfoliation. Just like scrubbing off the outer layers of your skin when it's dry, you're exfoliating your skin. It's kind of the same thing. The rock is peeling away in layers. And fourth, we have biological activity that can cause mechanical weathering. So biological means stuff that's alive. So basically this is when you have plants or animals that are breaking up rocks. So whereas frost wedging was water and ice cracking rocks open, you can also have plant roots that get into the rock like in this picture here, and that's through a process called root wedging. So anytime you see a big cracked rock, if there's a tree in it like this, it was from root wedging, and if there's no tree, it was probably from frost wedging. And then also some kinds of animals like this little guy here, the cliff swallow, they'll dig away at like sandstone cliffs and make their little nests in there. Okay, so the other main type of weathering is chemical weathering, and so now this occurs when there's actual like chemical change of the rock into different substances, different compounds. A lot of times this involves it reacting with water or oxygen somehow. So whereas physical or mechanical weathering was like ripping up a paper and you still had paper to smaller pieces, now you can think of chemical weathering as like burning a piece of paper. It's a completely different substance now. It was paper and now it's ash, so you've completely changed the substance. Another example is like dissolving a sugar cube in water. As that sugar cube gets dissolved, it's like undergone a chemical change. This occurs faster in warm and humid climates because chemical reactions happen faster when the environment is warmer. And then also, like I said before, a lot of these have to do with rocks reacting with water. So the increased humidity can increase the rate of weathering. And then as far as the way that chemical and mechanical weathering work together, as rock is physically or mechanically weathered into smaller sediments, that exposes more of the surface area of the rock. And the more surface area is exposed, the more like water and oxygen and whatever can get at that rock, and so you increase the rate of chemical weathering. So more surface area, faster chemical weathering. So now we'll discuss the specific types of chemical weathering first. It's called acid rain. Acid rain forms when the little cloud droplets, the liquid cloud droplets, mix with different gases. Specifically, carbon dioxide is one that can form acid rain quite often, but also things like sulfur dioxide and nitrogen dioxide can also form acid rain. But in any case, whatever the gas is that mixes with the water, it creates a little bit of acid in that water, and so now you have rainwater with a lower pH than usual. And that acidic rainwater is really good at dissolving rocks that have a lot of calcium-rich minerals in them, so like limestones and marbles. Like these, this headstone is made of marble, and you can see that it has dissolved quite a bit over time, versus this particular headstone is made of granite, which is very low in calcium-containing minerals, so it's much more resistant to this type of acid rain. And then this is an example of a marble-carved statue that's had its features eaten away by acid rain. The most common acid that is formed in acid rain is called carbonic acid, and that's when you have the carbon dioxide that's mixing with the rainwater. You get carbonic acid. Next we have acidic groundwater, and this mostly happens when you have some types of minerals like in the soil or the rock that's underground, that when they dissolve into the groundwater, they also lower the pH. So like similar to how acid rain forms. And so now you have a low pH of groundwater, and that basically dissolves it's really good at dissolving calcium-rich stuff that's below the surface. So this is how caverns like Lewis and Clark caverns formed in this way by acidic groundwater. Certain places in the country are susceptible to sinkholes, where like the ground underneath an area will just be dissolved away, and then eventually it will collapse in a sinkhole like is going on right here. And all of these caverns and sinkholes, altogether, they're just called karst topography. So here we have a map of the United States showing a bunch of different places where karst topography can be found. The more acidic the groundwater is in a region, the more likely you are to find caverns and sinkholes and other karst topographical types of features. Next type of chemical weathering we have is called oxidation. So now this is when materials in rock are reacting with oxygen in the air. You're familiar with this like with rust. Iron, when it oxidizes, when it mixes with oxygen, it will turn a kind of an orange color like is going on in this rock. And another common one we see like in roadsides in Montana is copper. When copper reacts with oxygen, when copper oxidizes, it will turn this green color. So the actual minerals inside of the rock are undergoing a chemical reaction with oxygen, and that's changing their color. And then the final type of chemical weathering is through these organisms called lichens. And this is colonies of algae and bacteria and fungi that all live symbiotically together on the surfaces of rocks, and they actually digest the minerals of the rocks and eat them. So this is like an example of a biological activity causing chemical weathering.